Hi, my name is Xavier Devroy, and in this video I will explain how, with my colleagues Moussa Amrani and Benoit van der Roos, we defined a series of projects that share a common theme to provide a transversal understanding of common notion seen in separate courses, and introduce soft and project skill in a progressive way. Acquiring soft and project skills during their study is essential for computer science students to integrate large development teams after graduating. Project-oriented learning offers interesting opportunities for teachers to tutor students and allow them to acquire and train those skills in addition to the core topics of the course. However, since most existing curricula requires courses to be as independent as possible, for organizational reasons for instance, some topics are covered in different courses slightly differently. This repetition is interesting to grasp difficult notion, but may also hamper students' understanding when closely related concepts are presented differently. In our setting at the University of Namur in Belgium, the two first projects happened during the last year of the bachelor program in computer science. The first one is part of the analysis and modeling course, where students develop their abstraction capabilities to analyze specific domains and model those domains using the industry standard UML. The second project is part of the Programming Language Theory course, where students learn the basics of language and compiler theory. The last and largest development project is spread over the 3 months of the first year of the master program as part of the software engineering course. There, students are put in a quasi-realistic development context to illustrate the challenges they will face during their professional careers. The modeling and compiler projects share a common theme, emphasizing the complementarity of the analysis and modeling and the programming language theory courses. The compiler and software engineering projects share a common technological infrastructure, allowing students to train their project skill like code version control, testing, and continuous integration. All 3 projects also require students to develop their soft skills through collaboration, teamwork, and project management activities. The common theme of the modeling and compiler projects is a turn-by-turn world game entitled Live Long and Die Hard. In Live Long and Die Hard, 2 explorers, Steve Intax and Scipion Edward Mantix, compete on different maps to find a grail and progress to the next level. The explorer have several primitive actions at disposal to scan the environment on the nearby cells, for instance if there are enemies or items around, and decide which action may be taken, like using an item or fighting an opponent. We built the game engine by extending the 2D roguelike tutorial available on the Unity Marketplace. The modeling project consists in specifying 2 DSLs through models expressed as UML class diagram with OCL constraints. The first DSL describes the world and its component, while the second DSL describes the behavior of the explorers and their strategy. Students work in pairs using Modelio and are encouraged to discuss their understanding in an online forum where teachers may give precision about the project. The project has non-compulsory milestones to help students assess their progress, and witness instances and specific constraints are provided to test their diagrams. The compiler projects run in parallel with the course. It starts with a half-day training where we present the DSL describing the behavior of the player and the target language, and introduce the different technologies used during the projects. Students then work in groups of 3 to develop their compiler based on a provided specification. The project is divided into milestones, each associated with a set of compiler functionalities and corresponding hidden test cases. Students have to reach the different milestones at given deadlines by passing all the tests associated with the milestone. The assessment is automated using a continuous integration server that provides students feedback each time they push their code on a Git server. For the software engineering project, students are randomly divided into teams of around 5 members in charge of a software development project. Each team starts from a loose elevator pitch as a project description and has to elicit the appropriate requirements through interviews with the customers, role played by the teaching team. All teams follow a customized agile development method, sometimes referred to as the Water Scrum Fall, supported by Jira Agile tools. The business case targeted by the project varies each year, but consists of a distributed application with multiple types of users interacting concurrently. Except for Jira and SonarQube for quality control, little to no constraints are put on the development technologies and tools the students have to rely on to achieve their goals. In April 2018, we evaluated the recent change introduced in the modeling and compiler projects and their reception and helpfulness for the software engineering project. First, we sent an online questionnaire to former students who did the project in the 2015-2018 period and received 60 answers in total. Second, we conducted semi-directed interviews with students from different categories of grades for a total of 13 interviews. 55% of the respondents perceived the modeling and compiler project as challenging. In comparison, 80% indicated finding them interesting or very interesting, and 45% thought the project helped or were essential to understanding the theoretical lectures. Among students that passed both the modeling and compiler project, 30% considered that having a common team did not help them start quicker on the compiler project. In comparison, the shared content helped 46% of them to better understand the topic and the project assignment. 52% of the respondents indicated that the modeling project prepared them for the software engineering project. In comparison, 30% of the students indicated that the compiler project prepared them for the technical aspect of coding for the software engineering project. Interestingly, 48% of the respondents also indicated that a compiler project prepared them for the testing aspect of the software engineering project. In conclusion, our initial insight encouraged and motivated us to pursue our effort to integrate and align the topics and teaching requirements of the three projects. That's all, and if you want to read our paper, it's available in open access and contains more detail about the three projects and the result of our evaluation.